Okay, now it's okay. Okay. Now you should be able to listen to me. You hear me? Okay, perfect. I'm sorry about that. Okay, so let's start again. Sorry. Welcome to this webinar. I make the presentation faster, so I will gain the time I've lost. The live chat is disabled, so please use the question tab below the video for the questions. And I think we can start without any more time. Yeah, 2 polls. Please answer the polls. So I can tailor my talk better if I know your answers. Okay, I know someone responded, but not all. So please, thank you very much. I see the poll is now. Yeah, perfect. Okay, so let's start. This webinar is the title is EyeROBO Platform, the AI Revolution in the Eye Care. There will be a huge initial part in which I will explain what EyeROBO is and why it is important. And then a smaller part about the development roadmap. Okay, so let's start with the definition of what we think EyeROBO platform is. It is an artificial intelligence-based cloud platform for the screening and diagnosis of the pathologies of the eyes and beyond. I know that some words may sound strange for a lot of you, so I would like to explain a little bit some terminology. So what is artificial intelligence? It's a theory and development of computer system able to perform tasks normally requiring human intelligence. We actually, in our first application, we use machine learning. That's why I was asking you the difference, because machine learning is a part of artificial intelligence. And to give you an example of machine learning, is when you try to teach a computer, a machine, to perform a task, and without exactly telling them what to do, but by examples. For example, you can write a routine in order to sum 2 numbers. You write, take the first number plus the second number, and the answer would be always correct. In this case, we are doing something different. We are trying to give the computer a couple of numbers and the result. We do it many times, so the computer will learn by its own what operation it has to perform to the numbers. At the end, it will be able to sum 2 numbers even without knowing what the sum is. This is what machine learning is, basically. Cloud-based, cloud platform is the hardware and operating environment of a server in an internet-based data center. So what this means is that the intelligence is not lying inside the instrument, but is lying on a cloud server. Regarding screening and diagnosis, I think I will tell some words later on during the presentation. I want to concentrate also on this beyond at the end of the sentence. It's because we don't want to limit this platform only for the eye. We want to add more data, we want to add more measurements, and be able not only to work on the ophthalmology world, but if we succeed, we want to enlarge the potentiality of this platform. So in the title of the webinar, it says a revolution. So I was looking and trying to find some sentences about this, and I found this one. The thing that made me surprised was that the word he used, right? He says that for building a revolution, you do not need to build a software, you do not need to build an instrument, you do not need to build a marketing strategy, whatever. It says a model. So it is very, very interesting, because we are talking about not about a single software. We are talking about an environment, a model that we want to exploit, and then Adaptica with eVision Group, which acquired Adaptica a couple of years ago, we want to build. So it's very important for us. And let me start with a cake and a question. So basically what we want to do, it's like we want to build to make a cake, right? We want to create value for us and also for you all, customers, distributors, users. It's based on data. It uses AI, artificial intelligence, and we want something that is easy to use. Like with a cake, it's like the cake should be delicious, right? But what happens usually is that you have a big gap between the data and the value, okay? And usually what happens is that the cake is very ugly and it tastes horrible, and it falls down to this gap, because it's not so easy to close the gap between the data and the value. You need a lot of things, okay? A lot of ingredients, a lot of tools. And while thinking about this webinar, I was putting together all the pieces and try to see whether we have all of them and why we have all of them, and why it is interesting, this way of delivering the value through the use of the data. So basically, in order to succeed, you need the willing, okay, to do something new. This is the environment, okay? If you don't want to do a cake, you never do it. Understanding, without knowing the recipe, is impossible to deliver the cake. Then you need the tools, you need the algorithms, you need the data, ingredients, okay? You need the fruits, you need the sweets, you need whatever it needs to make the cake. So those are the data. You need analysis. I mean, I think if you have a guest at home, you always try before to do the cake, before delivering it, before letting others test the cake. And you have also the users, so the one who actually is eating the cake. Yeah, maybe in this day you eat yourself, because a lot of people I know are in quarantine, so a lot of cakes are coming out. And I mean, if you have all these ingredients, it's likely that you have a very good cake at the end, which can deliver value to everyone. And I think Adaptica plus eVision has all of those. We strongly want to deliver high-end devices that revolutionize eye care. We have the knowledge on how to get there. We are also learning a lot every day. We can rely on cutting-edge algorithm and skills with the people we have in our group. We have data. This is very important. We have data flowing from more than 20 eye care hospitals, clinics, and centers in China. I mean, for the first application we will see shortly, we collected all the data in a couple of weeks, which is amazing. And we have users. We have users, which means supportive distributors that can input good feedbacks. I think we can all get a great added value out of it. Okay, now this, it's more going into reality. We want just stuff that works. So I will go a little bit into the detail about what is the first application we are delivering with our products. What we call the EyeROBO 1, it is an anterior segment AI. So it's an artificial intelligence system that can detect cataract and keratoconus from the images we already take with our instruments. I know that from the polls that some of you doesn't know our instrument, so I suggest to go to our website and check it out. But basically, we do instrument that by acquiring images of pupils of the face and then the pupils can predict the refractive state. Since we collect those images, we could, in principle, use those images to feed an artificial intelligence system and try to see if we can get something else out of those images. So this is exactly what the first EyeROBO 1 is. It uses those images to give a hint about cataract and keratoconus. The system is designed from the beginning to be secured, although the first version of the algorithm uses only anonymous data, so you don't have to worry about security, about privacy, because there is no sensible data sent to the cloud. But it's already EPA ready. We are working on the EPA compliance for the whole system. And when we have that, we could also deliver a front end for the data management. This is some detail about the structures. You see you have the machines. The cloud structure is the one inside the dashed line, red line. So you have the storage of the pupils that are sent in the cloud. And you have the artificial intelligence engine, which actually elaborate the images and then send back the response. So the process is, of course, very fast, and you do not need to worry about anything, only to have the connection on the tablet or on the device on, so the data can flow from the device to the cloud and back. Okay, don't be scared about this one. I know it could be scaring. The algorithm, the machine learning, is based on convolutional neural networks, which is basically a machine learning algorithm used for images. The training has been done with more than 30,000 pupils. So here you have an example of how CNN works, for example, with faces. Suppose that you want to see among all those images which one is smiling, which one is sad. You feed those images, okay, and at every layer of the algorithm, the algorithm extracts some features. So you can see on the top the features it is extracting, okay. On the left there are the most low-level feature, like for example edges or lines. Then it becomes a little bit more complicated. So for example, one eye, the profile of the nose, and then at the end it can identify the face, okay. So what you do is that you let the algorithm work, and you tell the algorithm, this person was sad, this person was happy. And then when the algorithm sees a face that it never seen before, it can predict whether it was sad or happy. So this is the same algorithm we use for the cataract and keratoconus algorithm. And those are the images we feed the algorithm with. So usually in the normal condition, normal eye without any disease, Those are the pupils images we get. So you see that at the top there are very smooth transition between light areas and dark areas, whereas some example of keratoconus pupils and cataract pupils are below. You see the difference, right? If we zoom in, those are the features we expect to find in those images. As I was saying before, you have a smooth transition between light and dark in normal eyes. Due to the shape of the cornea in keratoconus, the light doesn't follow the same path, and you have dark light, dark pattern, or the opposite, like dark light. But for sure you don't have the smooth pattern you have on normal eyes. In the cataract, instead, you have what's called a speckle pattern. So due to the fact that the opacity of the lens is not uniform, you have a zone where the light can go through and other parts in which the lights cannot go through on its severely stopped. So you have those speckle pattern. So we took basically a lot of patients with cataract and keratoconus, which present this kind of pattern on the pupils, and we feed the algorithm by saying to the algorithm, this was a cataract, this was a keratoconus. So the algorithm learned how to do that. So on the data set we acquired, we have an accuracy of 98%. What does this mean? Usually what you do is you take your whole data set, you divide 80-20 or 70-30, and you use the biggest part in order to train the algorithm and the smallest part in order to validate your algorithm. And with the validation part, 98% of the cases, the answer was correct. This doesn't mean that the algorithm will never miss a case, right? Because it's the nature of the algorithm. We are adding more data, and we, of course, in order to give a diagnosis, we need to do a clinical validation. So this is in plan for, but I'll come to that later. But this was just letting you know that with the data set we have, which is quite huge, we have 98% accuracy. Another thing is that it's not that we invented the wheel. So this is, we tried many algorithms. You can see them on the right. Doesn't matter what these letters mean, but we've done in the past month a lot of work in order to optimize the algorithm and to get the highest accuracy possible with the data set. Okay. The roadmap. So this is the first, as I was saying, application that we developed for the cataract and keratoconus. This will be available with the version 5.5.0 since April 24th, this month. We were expecting to deliver it at the beginning of the month, but we had some trouble for testing due to the coronavirus situation. So we decided to take a little bit more time. And the other thing is that this application is patent pending, meaning that we issue a patent and we are waiting the response of the patent office. We are going through clinical validation, as I was telling before. So some functions are present on the machine, some are not at the moment. We cannot give now a diagnosis, so a clinical evaluation of what is happening, because we missed the clinical validation. But we will start this in September. So hopefully next year we also can give the diagnosis. For the moment, what you will see is that when you have an error on the machine, so the machine cannot take the refractive measurement, if there is a case, you will be prompted by a message that there could be a problem on the anterior segment. For the moment, we do not diversify cataract from keratoconus, exactly for the reason I explained. But this is a process. So basically, this is just the first application, the beginning of the process that will let us hopefully to certify the entire engine online as a medical device. We will add also a portal for the user, so to let they manage the data. This has the same problematics, a little less actually, that the diagnosis, because we need to be HIPAA compliant in order to have all the cybersecurity countermeasure necessary for the product to be a medical device ready. But this will let you to do, for example, second order opinion, telemedicine, and this will be available hopefully at the end of the year. And the other thing is that we also are collecting data every day, and we want to add other functionalities to the machine. For this, I cannot do any promise, because if not, then you will say that we don't deliver the product. But it's very early stage, so basically, the process, to go to the market is long. So, but just to let you know that we are working also on this. Another thing I want to say is that as you have seen, we are more focused on the model, because only creating a new model you can really do a revolution. So this is a data cycle in which every iteration it is possible to increase the function and the value. Okay, and it is very important, this, because it may take a little bit longer, but the important thing is that we are not myopic, right? We are not focusing only on one application. We want to really to try to, at every iteration, add something new and something that is valuable for our users, for the patient, and for our customers. So basically, this is a standard, it's called CRISP DM, data mining process, which starts from business understanding, data preparation, modeling, evaluation, and deployment. And then you start over again. Every time you have a new data, you have to understand them, you have to prepare them, model, do the algorithms, evaluate the output, and then deploy to the market. This is a process that goes on and on. And there is also your role in this process, which is from the deployment to the business understanding. You may have feedbacks, you may have comments, you may have things that we didn't consider, and it's very important to have all of you participating in this process. So I think I'm okay. I was a little bit faster, maybe, but I'm glad to answer all your questions. Let me see. Okay. Okay, I have a question from Nayan. No, it was disappeared. I cannot see the question. Okay. How can you distinguish eye astigmatism and keratoconus? Okay. The correct answer is we don't know, and I explain. So the images of the pupils you have seen before, Okay, those ones, okay, are basically the spherical power taken from one meridian, okay, from one angle. So basically, the cylinder is no difference from a sphere with this respect. So even if you have a very high cylinder, this image will not change in its basic features. It will change, of course, the intensity, but it will always have this pattern. Whereas a keratoconus, okay, when illuminated from the same position, will have a dark zone behind. Okay, so this is the thing that make us believe that the algorithm can distinguish them. A more interesting question will be, how can we distinct very, very early stage keratoconus? And this we are working on. We don't know this answer yet because we need more data on early stage keratoconus to see whether we can at which stage we can spot them. Yeah, this is also the same answer I will give Varis Palikaris. Can you perform cataract grading based on the data so far? So far, no, but it's only a matter of the data we have. So basically now we have a data set which contains also only, cataract data without classification. But if we start collecting data on different type of cataract, different stages, and we feed the algorithm with those new data, then we may be able to distinguish also that. Of course, this is our dream. Our dream will be to distinguish not only the type of the grade of the cataract, but also in this case to distinguish early stage cataracts, to see how far we can actually get them. Okay. Given that is cloud-based, does that mean that you must always be connected? This is a question by Daniel. Yes, for the moment, you have to be connected. In the pipeline, we have the development of a sort of a posteriori analysis, or call it a detached analysis, in which you can upload your data even later on. But this version 5.5.0, you have to be connected. We know that this could be a problem in some situation when you, for example, go where there is no internet connection, and then you come back home and you want to see your data. There was no time now to address this problem, but we have it in the pipeline for sure. This would be one of the main activities for from now to the end of the year, to be able to save all the data, which we already do, and then have a sort of a pipeline of analysis to, as soon as you are connected, to send them on the cloud and give back the response. The thing is that it's quite difficult to do it if you don't have the proper managing tool for the data you send to the cloud, right? So this will be probably done together. Are any of these features included in the present Win Kaleidos equipment? If not, when are you planning to? Yeah, this is a question by Juan, which is asking basically when this will be available. This first application, which is the keratoconus cataract analysis, and also the EMR connection and the SEER app, it's part of the KALEIDOS Plus, which will be available since April the 24th, this month. It is basically an update software, but I think you can ask more details to the sales team, and they will give all the information you need. But yes, it will be available very soon. Apart from cataract, what other diagnoses are in pipeline? This is a, how to say, we have something, I cannot really tell you now, because, it's very early stage. So we do not know whether those things can be done with the actual instrument or requires new, different kind of hardware. But yes, we are working on other things. I'm sorry, I cannot tell you details. But as soon as we have something, you will be, of course, the first to know. Pia, how do you see the input of ECPs in the development of these tools? Can you, Pia, write what an ECP is? Because I don't know, and then I'm glad to answer. Carlos, will this be available to current user of KALEIDOS? Yeah, this is already answered, I guess. So in principle, yes, there will be no additional hardware. And I think you should contact the sales team for more details. I'm reading the questions. Okay, what anonymous mean in this aspect? Does it mean that the diagnostic cataract keratoconus and then the ophthalmologist noted separated? No. Okay, so the question was, what does it mean to be anonymous in this case? The output of the algorithm will be attached to the exam. So you will see exactly what is happening if it is happening. The anonymous data is because of regulatory issue regarding the transmission of personal data to the cloud. So basically, at the moment, even if you set the name of the patient or the age of the patient, those data are not sent to the cloud because this requires us to protect the system and infrastructure, and not only to do that, which we already do, but to demonstrate we do it, to have the certification for that. So this is the only reason why I'm talking about anonymous data. The takeaway from this is that you do not need now to be worried about anything related to data protection, cybersecurity, GDPR, whatever it is in your country, because the data that are sent to the cloud are anonymous. Hope this answered to this question. Yeah, Faisal, yes, this is a software update on the current to win KALEIDOS. As I told to answering the other questions, Davide and the sales team can give you more details about that. Also, Karim, I already answered your question. Can we detect the level of the keratoconus? For the moment, no, but we hope we can do as soon as we have the label data of different level of keratoconus. Okay, how long will the data last in the cloud? Will there be storage challenges? Okay, so we designed the system to be not worrying about this problem. We store the data, the pupils, even though we do not store the personal information, for a simple reason, which is customer support. Because we need to know and to see what is happening. We could not even store the images at this point. But it is, of course, good when in the future you can basically access your own data, your own patient's data. Regarding the storage, all the technical aspects of the system, there will be no problem because we are using a very, very big infrastructure and scalable. So basically, at the beginning, it will scale as long as the data will be higher and higher. There should be no problem. Also regarding the fact that downtime or things like this, or number of connection, multiple connection, there shouldn't really be no problem regarding that. It's also a thing that we have to guarantee in order to deliver these kind of systems. Let me see if there are other questions. Is the data open sourced? Okay, no. For the moment, the data is not open sourced. I don't know now whether we want we would like in the future to make it open or not. It may be a possibility to evaluate. We didn't evaluate it so far. So for the moment, the data are private, meaning that now they are stored anonymously. In the future, of course, the user who buy our machines, we could be accessing those data, the data that he is taking. So every machine will have its own, it's like it has its own data center with all the data the machine has taken, and then the doctor or the user will be able to see them. Okay, I have a question from Trupki. Does it interface with any other system? How do I collect results from this and record it in a system? Okay, so with the 5.5.0, actually we are introducing the EMR connection, which is not done specifically for one EMR, but is a method of exchanging data from our machine to the external world through a shared folder and a common CSV file. So basically, you can connect to every system as soon as you read how to do it. Basically, it's very simple. You create a shared folder, you put a file there to start the measurement and to input the data from your patient, and then you collect the result from the same shared folder. So this is the way we are addressing this problem. Okay, I have a question from Carlos, who is asking if there are any chances that we could also note the dystrophies and the leukomas later on. I cannot answer this, but I mean, it's because I'm how to say, we didn't look into that. I cannot answer positively or negatively. So we don't know. Basically, it may be possible, but I have no answer for this. Faisal asks how fast we will receive the output of the diagnosis, and how will the output look like. Okay. Okay. So the response will be very fast. No more than a couple of seconds. And if the system detects any anomaly, it will pop up a message with the words that say there can be a possible anomaly in the anterior segment of the eye. So this is what you will see. If the eye is normal, you will see no message. You will know that the analysis has been done because you will have a cloud icon, which will be green if everything goes correctly, or red if the connection has some problem or the screening could not be executed. So basically what you see is if everything goes good, you see a green cloud icon and you're fine. If something goes wrong, you see the green cloud icon, but a message will appear, meaning I've done the analysis and there is something wrong. We will add the keratoconus and cataract specifically when we have the clinical validation done. Haddad is asking if we can have a cornea-like image, like a topographer. No, it's a completely different thing. We are working at 1 meter distance, and the way we address this problem is completely different to a topographer. So basically, we cannot give all the information a topographer gives, because it's it's a completely different thing. The good thing is that we can still do it from 1 meter distance with the instrument that we have actually on the market, and this is a thing I think that is very remarkable. Okay, question are, I'm trying to read them, but okay. No, there's something strange on the question. Sometimes they disappear, and sometimes I can read them, and sometimes open for. I think I've answered all of those questions. I think there were many more questions, but I cannot read them anymore. Okay. I have another question now. So this is more predictable than initial keratoconus. I don't understand this question. What do you mean by more predictable, Igor? Can this help you with fitting contact lens by any means? Good question. We don't know, but we will look into it, whether it will be possible to see to help with contact lens fitting. That could be a good idea. Thank you. Okay, and Sylvia is now writing that if you have more questions, you can also write an email to webinar Adaptica. Will the product have a DICOM interface to connect to most EMR system? Okay, this is a good question. We are working also on DICOM. For the moment, there is no DICOM connection interface. We are planning to do it in 2 stages. The first one is produce a DICOM output, and the second one is instead connect to the DICOM PACS. This is a thing we have in the pipeline. For the moment, there is the EMR connection, which is basically the same way that other instrument uses. Okay, Igor replied, sort of aberrometry condition of the cornea, isn't it? Not really. It's not really an aberrometric condition. Okay. We are working on something related to the aberrometry of the cornea. Okay. But this application in particular is not strictly an aberrometry. So basically, it's a two level system. It's yes or no based on the feature that the algorithm extracts from the images, which are not exactly the topography. Okay, so I cannot guarantee that this can work. We have to look more into the details of which feature are extracted and whether this feature will be are similar or connectable in some way to the aberrometry condition. For price, I think it's better to ask to the sales department by email. Okay, this is another good question, Guillermo. If we can detect the visual acuity if the cataract allowed, and the answer is not at the moment. So what we can do is, if the person has a cataract but still the refraction can be measured, the machine will give the refractive measurement. If the refraction cannot be measured, then the machine will probably give that there is a possible problem on the anterior segment. Okay, someone is leaving, so thank you all for attending this webinar. If you have other question, please don't hesitate to write the sales department, and they will forward the question to me if they cannot answer. And thank you all. And just want to remind you that we have a series of webinars, so we will be very happy if you can participate also to other webinars during this week and the following weeks. So thanks a lot for attending. It was a pleasure for me, and I hope you enjoyed it. Bye-bye.